session. I will share my screen first. Uh, just a minute. I need to share the screen. All right. I hope everyone is seeing the screen. This is the second day of our quantitative primary data analysis training using SPSS 27 online training using Zoom. And we are still at basic level. Today is 30 December 2023. Time is 6 to 8 p.m. And we also have three sessions today. So we will start today's training. Uh, Yesterday, we have discussed a number of things regarding the SPSS, like the basic overview, basic environment and data management in SPSS, like screen layout and its tool, menus, etc., like questionnaire survey and codebook creation, like basic of data entry for value label and level of measurements. Then we have discussed the missing value and demographic analysis. We have also discussed to enter the data and analyze the missing values, identification and remedy. One of the missing value technique I didn't discuss yesterday just because of the lack of time. I will discuss today. Then we have also discussed yesterday summarizing the demographic detail, cross tabulation of demographics. Then at the end, we have discussed the reliability analysis, variable computation, and descriptive statistic of composite variable, where we have discussed how reliability analysis is done, how the computation of composite variable is done, and how to estimate and report the descriptive statistics. Today, training session 1 is 6 p.m. to 6:40 p.m. Then session 2 is 6:50 p.m. to 7:30 p.m. and session 3 will be 7:40 to 8:20 p.m. Before starting today's session, I would like to recall how missing value analysis can be done with another method, because I have skipped the second method yesterday. So I would like to let you know how the missing value analysis can be done with another method. That another method is known as interpolate, linear interpolate method. Yesterday, I have discussed the series mean method, but there is another method of missing value analysis, which is linear interpolate method. There is a slightest difference between the technique of considering the missing values in your data. The series mean basically takes the mean of the series of your data of your column of the specific variable that you are interested to understand the missing values, while the linear interpolate method consider whenever there is a missing value in your data, it will consider the previous value of the missing cell and the next value of the missing cell, and it interpolate the previous and the next value, and then consider the missing value by taking the average of previous and next value and count that value as a mean of previous and next value. So I would like to let you know, I will take an example data set to let you know the procedure. Let's we have a data set of day 1. This is our data set for yesterday training, and we have a lot of things over here, like I have MB. I share the screen again. Let's suppose that we have some missing values like this, and let's suppose this. So there were two methods that normally the researcher use in analyzing the missing value in SPSS. The one is called series mean, and the second is one is called basically linear interpolation. Linear interpolation. So yesterday we discussed the series mean. In series mean, basically the technique consider the mean of the series, the values which are appearing in your data set. The technique consider the mean of those values, and then on the basis of the series mean, it will automatically estimate uh, the value which is missing in your data as a mean of the series. The interpolate method basically consider the previous value and the next value of the missing cell, and it will take the average of both missing previous and the next value, and will calculate the missing value on the basis of it. So first of all, I would like to let you know what we have discussed yesterday. Let's suppose we have MB1 with the missing values. So the first method is series mean method. Just we need to do is to click OK button, and it will calculate the series mean, and you can see the value. You can see the value of your series mean like in your data set over here. I said that you can copy and paste these values to your original factor, but let me tell you how we can analyze the missing value with another method which is very popular among the research community, that is interpolation method, linear interpolation method. That is another method. You can remove it from here, and you can take it again here, because we are taking the interpolate method. Uh, First you need to check linear polation, and then you need to change the interpolation, because series mean is still appearing here. So we need to change it, and now you can see that linear interpolation is being appearing over here. You just need to click OK now, and it will create your missing data. It will create the average value of your missing data. Now you can see the values again with the another method. So some of the researcher prefers this method instead of series mean, because it takes the values before and after the missing cell. So you can just copy these values, just select it, and just copy these values into your missing value column. So this was the remaining part of yesterday training. Now I would like to start the today's part, the today's session. What we are going to do today is basically the graphical representation of the data using different types of graphs. All right. These are the contents of our session one, which is 6 p.m. to 6:40 p.m. It will be discussed with you in detail. Like in segment one, we will discuss histogram with its different types, how to estimate it, how to interpret it, which type of data requires the histogram, why we prepare it, what does it tell. Then in segment 2, we will consider scatter plotting with its different types and shapes. Which type of data requires scatter plotting, why we prepare it, what does it tell. Then in segment 3, we will consider frequency distribution with its different types, which type of data require frequency distribution, why we prepare it, what does it tell. So this will be discussed in our session one of today's training. So let's discuss the histogram first. Histogram, with its different types, is a histogram is a graphical representation of the distribution of data. Basically, when we are discussing the histogram, we are discussing the distribution of your data, how your data is distributed, along with your number of values, along with your data sets, to determine whether the distribution is right skewed, left skewed, or basically it is symmetric. Basically, there are three types of distribution that you can form with the histogram. Either it would be symmetric distribution, or it would be negative skewed distribution, or it would be positive skewed distribution. In case of right skewed or positive skewed distribution, if the mean is less than the median and the tail of the distribution extend more to the right side, the distribution is right skewed. That looks like this. If the tail spread on the right side, you can say it is a right skewed distribution. In case if it is left skewed, if the mean is greater than the median and the tail of the distribution extend more to the left side, the distribution is left skewed. Like this, you can see that the tail is spread on the left side, while in case of symmetric distribution, it is bell shaped. The more ideal shape of your distribution, if you create the histogram of your data set, the ideal shape which consider or which confirms the normality of your data is symmetric distribution. So if we need to take a decision based on the histogram whether our data is normal or not, we need to see its distribution. So if the distribution is in symmetric shape, means it is bell shaped, so we consider our data set to be the normal. The second thing, the more important thing you need to consider, that always check the distribution of your dependent variable or your endogenous variable. You don't need to check the shape of the shape of the distribution of your independent variable. So you need to check the shape of the distribution of your dependent variable only. So for the purpose of normality, always check the histogram of your dependent variable. If its shape is symmetric, it means your distribution is normal or parametric. You can consider the parametric method of testing the hypothesis. But in case your distribution is negatively skewed, positively skewed, or for our dependent variable, you need to reconsider your data set. You need to increase your sample size, or you need to see whether there are some missing values, whether there are some outliers, or whether there are some other issues with your data that need to be corrected before a further analysis is performed. Right. Next, what type of data, which type of data required histogram? There are three types of data with which you can perform the histogram. You can take the continuous data, like the age, the income, the test score. You can take the interval data, like interval scale from histogram, like we take the Likert scales, like strongly disagree to agree, that is interval, as well as uh, the simple scale. You can take the discrete data also, which is countable data, like number of persons, number of cars, number of anything that is countable is discrete. So these are the types of data that you can take to perform your histogram analysis. Why we prepare histogram? What is the purpose of preparing the histogram? The basic purpose of preparing, there are four purposes of preparing the histogram. The first purpose is to seeing what is your distribution, whether it is symmetric distribution, whether it is right skewed or left skewed. So first thing you need to see is the distribution analysis. The second thing that we can assess from histogram is identifying the pattern. Histogram let us know whether it is normal distribution, skewed distribution, or multimodality. The third thing we need to check is outlier detection. From histogram, we can check if there is a outlier in our data, outlier can stand out in a histogram. When I perform the histogram steps in SPSS, you will see that there might be some points that may stand out from the histogram, aiding in their identification. So it will also let you know the data exploration. They are essential for exploring the central tendency and variability of the data. uh, what the histogram will let you know, the histogram will let you know the shape of distribution, whether it is symmetric, skewed, bimodal, multimodal. It will let you know the central tendency like mean, median. It will also let you know the variability. It will also let you know the outliers. So isolated bars in a histogram will consider as outlier. So what are the interpretation guideline if we have created a histogram? So what are the things that we can interpret from it? We can conclude whether it is normal distribution or not. We can conclude whether it is left skewed, right skewed, or whether it is symmetric diagram or bell shaped diagram. We can conclude about the central tendency of the data, if peak near the mean or median. We can also conclude the variability of the data. If there is a wider spread between the bars of the histogram, we can state that it contains the higher variability. Uh, in addition, if there are some isolated bars or tails beyond the typical range, we can say that there are some outliers. So let's start how we can perform these steps or these things from SPSS. Let's have a look on our data set. As I have told you, the type of the data that we can use to perform the histogram. This was the type of data. We can take the continuous data, interval data, or discrete data to perform the histogram function. Let's take some discrete data first. We have here the gender. Basically, the gender will let us know that how many are male, how many are female. So how to perform the histogram? You need to go to the graph. There are two options available here. One is the chart builder and one is the legacy dialogues. You can use both of them, but I will let you know how to use the chart builder function to perform different types of charts. Like you need to just click it. You need to press OK. uh, a window will appear over here. What you need to do is simply take the simply you need to take simply the target variable of you that you want to perform your histogram operation. Like I would like to take the age, but first I need to select which type of chart I need to perform my function. I want to create the histogram. So click on it. It will create the diagram like this. Now, if I want to create the histogram for the age variable, I just need to drag it and paste it in x-axis, and it will create the histogram chart like this. Then I need to click OK. You can see it is executing the file. Just wait a little. Yes, it is created. You can see the histogram of age variable. And can anyone let me know whether it is left skewed, right skewed, or symmetric? Can anybody let me know in a message box? In a chat box, can you let me know whether it is left skewed, right skewed, or whether it is symmetric, right skewed. Anybody else? Right, right. Well, it's mean there is a need to reconsider our concept. These are the shape of distribution. In case of negatively skewed distribution, you can see over here, in case of negative distribution, the tail of the distribution will spread to the left side. And in case of right distribution, the tail of the distribution will spread on the right side. So if we see our chart, our histogram, the tail of the distribution is on the left side. So it is left skewed distribution. But you need not to worry. Some of the people has give the right answer. It is negatively skewed. So thank you very much. You are attending this session with a careful consideration. I have already told you that you need not to worry about any independent variable, any your demographic variable in case the distribution is left skewed or right skewed. You just need to worry when your dependent variable is not look like a bell shape. Let's consider one of our variable as a dependent variable. uh, like I need to see which variable I use in my study as a dependent variable. Hello. All right. uh, I request all the participant to please mute your mics so that I can perform well. All right, I need to calculate a variable as a composite variable, as a dependent variable. Let's compute a variable, my dependent variable. For example, there is a bank market share. This is the factors of my dependent variable. So let's calculate the composite variable. I have let you know the computation of composite variable yesterday. Today I am repeating the procedure. You just need to select the statistical from function group, and you need to select median from the function and special variable. You just need to double click it and go to this bracket and double click your factor one by one and place a comma after every factor. You just need to double click again and again and place a comma between them. It is a way to calculate your dependent variable actually. So you can calculate it in a more easier way. So all the factors has been placed in a mean box. Just you just need to write the name of your variable like BMS simply and click OK now, and it will calculate the variable. The command has been executed. You need to verify from your data set whether it was calculated or not. So you can see the variable was calculated. Now the only thing that you need to check is whether your dependent variable is showing the normality or not, whether it is right skewed, left skewed, or whether it is bell shaped. So go to the graph bar, chart builder, click OK, and you need to again calculate it, the histogram of your dependent variable, which is BMS. Just drag it and place it into the x-axis part. And yes, it has been created. You just need to click OK, and you will see its chart. You can see the chart has been created. It is somewhat showing the normality, but it is not complete normality because some of the bars are up and some are downs. It is showing a type of curve bars or curve shape. You cannot say it as a left skewed or right skewed, but it is somewhat showing the normality. You need to check whether your values are whether your participant has answered the question in a right way, or you need to increase the sample. As the number of values in this questionnaire are low, that is why the number of values are just 139. A lot of researcher in different studies have indicated, or there is a benchmark by a lot of influential researcher. I have discussed that how many number of values should we consider while analyzing our primary data. They have suggested that you should have at least 350 observation to consider your data to be normal. While in statistic, there is a guideline that you should have a minimum of 30 observation to consider your data normal. So I would suggest that by increasing the sample size, we can resolve this issue, and we can make it a normal distribution. So in case our distribution look like this, it means that it should be upward from the middle, and it will be downward from left and right. It will become the symmetric, and we will consider it as a normal, right? Next thing that we can do is scatter plotting. Let's start to discuss what is scatter plotting and why we estimate the scatter plotting. A scatter plot is a type of graphical representation. Just a minute. Yes. A scatter plot is a type of graphical representation that displays individual data points on a two-dimensional graph. Each point of the graph represents the value of two variables, with one variable on x-axis and the other on the y-axis. So we can conclude that in case of scatter plotting, we should have two variables to compare and to estimate their relationship, their direction. Scatter plots are useful for visualizing the relationship between two continuous variables and examining pattern, trend, and correlation in the data. So types of data that require the scatter plotting, that is bivariate data, that is correlation analysis. In most of the cases, when we want to estimate the correlation between two variables in a graphical mode, we use scatter plotting. So in case of bivariate data, scatter plots are ideal for visualizing the relationship between two continuous variable. In case of correlation analysis, used for exploring the strength and direction of the relationship. It will let you know whether the relationship is strong or not, and it will also let you know whether the direction of the relationship is upward, downward, positive, negative, and so on. Why we prepare the scatter plot? It will visualize the relationship. Scatter plot provides a visual representation of the relationship between two variables. Pattern identification, it will helps to identify the pattern, trends, and potential outlier. It will also let you know whether your data has some outlier or not. It will let you know the correlation assessment. Scatter plots are essential for assessing the strength and direction of correlation between the variables, and it will also have the prediction and estimation capability, useful for estimating the values of one variable based on the values of another. Like if you would like to see the trend analysis, you can predict the values also. uh, Next is, what does a scatter plot let us know? It will let us know the direction, whether it is positive or negative. It will let us know the strength of the relationship, whether it has a strong relationship, whether it has a weak relationship. It will let us know the outlier. If some outlier is existing in your data, it will stand out as a point from the main cluster. It will let you know the pattern, whether there is a linear relationship or non-linear relationship. Well, I would like to let you know how we can create the scatter plotting from the data. Just go to the graph, chart builder, click OK, and you have the option of scatter plotting here. Just click it. It is the dotted plot. So just click it, double click, and it is requiring you the two variable. One is already here, that is BMS, and the second one is y-axis. Always try to locate the variable where you want to analyze the correlation. So let us assume that we want to see the correlation between mobile banking and ATM facility. So I will drag mobile banking into y-axis, and I will drag the ATM facility into x-axis, and it will analyze the relationship. You just need to click OK, and you will see the scatter plotting. Can anybody let me know whether it is positive, it is showing a positive relationship or negative relationship? Can anybody let me know? Here we are discussing Pearson correlation or Spearman correlation. We are just discussing a simple correlation. Actually, this is graphical presentation. In case of Pearson correlation, we will discuss the parametric data set. In case of Spearman correlation, we will discuss basically you can say the non-parametric data set. That is the content that I will provide in another training. In today's session, we are just discussing about the graphical representation. So most of the people had said it right. It is a positive correlation or positive relationship. When the relationship start from the left side and it goes upward to the right side, it will be considered as positive relationship. So we can say that there is a positive relationship between mobile banking and ATM facility. And if you want to identify the outliers, some of the points like this and like this may be considered as an outlier, which are outside from the main cluster. So you can consider it. So this is what we can deal with. Okay, thank you. Or all right, all right. Uh, we have only 4 minutes to complete the session one. So let's start on the third part. The third part is related with frequency distribution with its different types. It is also a part of today's discussion, that why we compute the frequency distribution and what does it tell. Frequency distribution with its different types. A frequency distribution is a tabular or graphical representation. Sometimes you can also calculate is graphically. I will let you know today how can we estimate it graphically. So a frequency distribution is a tabular or graphical representation of the number of occurrences or frequency of each distinct value or range of the value in a data set. It provides a summary of the distribution of values and allows for a quick understanding of the pattern and characteristic of data. There are three types of frequency distribution that we can consider as a tabular arrangement. The first one is simple frequency distribution. It displays the count of each unique value in a single variable. Second one is group frequency distribution. It will organize the data into interval or bins and shows the count of values within each interval. The third one is cross tabulation, that examines the frequency distribution of two or more variables simultaneously. Types of data that require frequency distribution: if you have categorical data, if you have ordinal data, if you have discrete numerical data. It means that in case of continuous data, you don't need to estimate the frequency distribution. You just need to consider the frequency distribution when you have discrete numerical data, ordinal data, or categorical data. Why we prepare frequency distribution? It will summarize your data, it will explore your data, it will identify the pattern, it will prepare your data for further analysis. All right, first I will let you know how to do the frequency distribution. You just need to go uh, to analyze, then click descriptive statistics, then click the frequencies. You need to see which of your data is categorical, like we have the age respondent data, which is categorical. Just move it over here, click on statistic button. There is nothing we can do with it. Then go to the chart. We have bar charts, pie charts, histogram. Let's select the bar chart and we need to see the frequencies. Just click continue, then click OK, and it will show you the bars of your data. It is showing the frequency of the data. That what we can conclude here, we can conclude that majority of the respondent are from age category of greater than 40, while there is a small number of people with the age category of 18 to 25. The time is going to end for the first session. There is a task attached with this discussion. I will again online after 10 minutes. So you need to complete this drill. Please take a screenshot of this drill. You have 10 minutes to complete it. Use your data set to create the following: histogram, scatter plot, or frequency distribution of any of the variable. If the variable is not created, you need to calculate the composite variable and create the histogram, scatter plots. In case of scatter plots, you need two variable. In case of histogram or frequency distribution, you need